Every morning, when you look up at the sky, you see the same giant glowing circle. The sun. But have you ever wondered, why does the sun shine? Why is it so bright? Why does it stay hot all the time? Today, we're going on a journey straight into the heart of our Sunday to discover the secret of its incredible light. Are you ready? Let's begin. The sun may look special, but it's actually just a star. Just like the tiny dots you see in the night sky. The only reason it looks so big and bright is because the sun is much closer to us than other stars. So yes, the sun is our closest star. That's why it lights up our whole world. From Earth, the sun looks like a small glowing circle. But in reality, it is enormous. If Earth were the size of a tiny marble, the sun would be as big as a giant beach ball. Scientists say the sun is so large that about 1 million Earths could fit inside it. Can you imagine that? 1 million Earths inside one sun. At the very center of the sun, called the core, the temperature is around 15 million degrees. That is hotter than anything on Earth. Hotter than volcanoes, hotter than lightning, even hotter than the hottest furnace ever built. In this extreme heat, atoms move wildly, crashing into each other non-stop. Most of the sun is made of a gas called hydrogen. Hydrogen atoms are tiny, but inside the sun they move like crazy. They bounce, crash, and smash into each other with enormous force. And sometimes, two hydrogen atoms stick together and become a brand new atom called helium. When hydrogen atoms combine to form helium, something amazing happens. A small amount of mass disappears, and that missing mass turns into pure energy. This powerful process is called nuclear fusion, and it is the reason the sun shines. In short, the sun works like a giant energy machine, making light and heat every second. But the energy created in the core doesn't reach the surface right away. Inside the sun, energy keeps bumping into particles, changing direction again and again. Like it's trapped in a giant maze. It can take thousands, even millions of years for this energy to travel from the core all the way to the surface. After its incredibly long journey, the energy finally reaches the sun's surface. The surface looks like boiling, glowing gas, always moving, crackling, and exploding with light. When energy reaches this layer, it bursts out into space as light. Once the light leaves the sun's surface, it travels through the darkness of space at an unbelievable speed, 300,000 kilometers per second. That's fast enough to circle Earth 7 times in just 1 second. Once the light leaves the sun's surface, it travels through the darkness of space at an unbelievable speed, 300,000 kilometers per second. That's fast enough to circle Earth 7 times in just 1 second. Without the sun, Earth would be dark and freezing. Plants couldn't grow because they need sunlight to make their own food. Animals need plants, and we need both plants and animals. So without the sun, there would be no food, no warmth, and no life on Earth. If the sun suddenly disappeared, Earth's temperature could drop to minus 200 degrees Celsius or even colder. Oceans would freeze, the air would turn icy, and the entire planet would fall into darkness. Thankfully, the sun isn't going anywhere anytime soon. The sun has been shining for about 4.5 billion years, and scientists believe it will shine for about 5 billion more. So we are right in the middle of the sun's lifetime. That's a very long time. Much longer than humans have existed. One day, far in the future, the sun's hydrogen fuel will start to run low. When that happens, the sun will grow into a huge red giant star. Later, it will lose its outer layers and shrink into a small white dwarf. But don't worry. This won't happen for billions of years. Now you know the amazing secret behind the sun's shine. Deep inside, tiny atoms are joining together, creating the energy that warms our world and lights up our days. The sun isn't just a ball of fire. It's a powerful star that makes life possible. In our next episode, we'll discover why the moon changes shape. See you soon.